It was late summer, 1944. The war in Europe had turned. The Allies were pushing inland from Normandy, and the skies above France belonged to them. Every morning the sound of thunder rolled across the countryside, not weather, but aircraft American Thunderbolts, streaking through the clouds, hunting anything that moved. But on one afternoon near a small airstrip east of Chartres, one of those mighty P-47 seconds limped home with smoke trailing behind it. The pilot had been hit by flak, and the aircraft's belly was bleeding oil. He tried to glide across friendly lines, but the engine coughed once, twice, then seized. The Thunderbolt came down hard in a wheat field, its landing gear shearing off. Miraculously, the pilot survived, but not for long. German troops surrounded the wreck within minutes. For most soldiers, it was just another downed enemy plane. But to a nearby Luftwaffe engineering unit, it was something extraordinary. The P-47, the American Jug, had become legendary among German pilots. They'd seen it dive faster than any aircraft in the Luftwaffe arsenal. They'd seen it take rounds from 20mm cannons and keep flying. Now, one sat before them nearly intact. The officers gave the order. The wreck would be recovered piece by piece and sent to the Luftwaffe's top test centre, Reich. The mechanics had no idea yet that the engine buried under that crumpled cowling, the massive Pratt Whitney R-2800 double wasp, would shake their faith in German engineering itself. How could a single American engine make lifelong craftsmen and proud mechanics whisper, "We never built power like this"? By the time that engine reached German hands, the P-47 Thunderbolt was already the stuff of frontline legend and frustration. Across occupied Europe, Luftwaffe pilots spoke of it with a mix of disbelief and respect. They called it der fliegende Amboss, the flying anvil. It wasn't elegant like their sleek Messerschmitts, nor nimble like the Fokker-Wulfs. It was huge, heavy, and unshakable. Whenever the Jagdgeschwader squadrons scrambled to intercept Allied bombers, the P-47 seconds were there, diving like meteors, scattering German formations, then climbing away with impossible speed. In briefing rooms across France and Holland, pilots questioned what made it so indestructible. Some blamed its thick armor plating. Others its radial engine, that huge air-cooled beast that refused to die even when hit. A captured pilot once told his interrogators that the Thunderbolt could take a cannon shell through the wing and still bring its pilot home. The Germans dismissed it as Allied propaganda, until one of their reconnaissance teams stumbled upon the wreck of a downed Thunderbolt near Chartres. The fuselage was torn apart, but the engine, that great circular mass of metal, was largely intact. It looked brutal, even crude, compared to the elegant lines of German Daimler-Benz or Junkers inline engines. But there was something about it, its sheer size, its design, philosophy, that fascinated the mechanics. They could sense it. This wasn't the product of delicate craftsmanship. It was the product of power, scale, and confidence. That night, the decision was made. The engine would be disassembled under guard, crated, and sent north to the Luftwaffe's most secret testing facility, Reich. The men who loaded it onto the flatbed truck had no idea that what sat under the canvas was more than a machine. Was a message from across the ocean, a message written in steel, oil, and horsepower. The transport convoy reached the Reich test facility under heavy security in early September 1944. The Luftwaffe engineers at the sprawling airfield had seen every kind of foreign aircraft by that point, Spitfires, Mustangs, Lightnings, all brought in for study. But when the American radial arrived, wrapped in tarpaulin and grime, even the most seasoned mechanics gathered. To watch, they rolled the engine into Hangar 7, where floodlights glared off the steel tables and rows of precision tools. The chief mechanic, Oberfeldwebel Karl Menzel, removed the covering, and there it was, the Pratt Whitney R-2800 double wasp. The room fell silent. At first glance it looked primitive, massive, overbuilt. 18 cylinders arranged in 2 staggered rows, like 2 engines bolted together. No graceful symmetry. No polished aluminum cowling, just a brute of machinery. But as the men circled it, their skepticism began to fade. Each cylinder head was masterfully machined. The cooling fins sharp and uniform, the wiring harnesses were color-coded. Something rarely seen in German aircraft maintenance, every fuel line was secured with redundancy clamps. It was not artistic engineering, it was industrial logic turned into metal. When they began dismantling it, they realized just how differently the Americans thought. The crankcase, a dense hunk of alloy so tough, it required special tools to open, weighed nearly as much as an entire Daimler-Benz DB 605 engine block. Yet every internal part was accessible, labelled, and replaceable. Even the spark plugs could be changed in minutes. Menzel shook his head. This engine, he said, was built for war, not for workshops. He was right. German engines were masterpieces of precision and delicacy. They ran beautifully, but they demanded constant care. This American engine, however, seemed designed to be abused, to fly hard, land harder, and still start the next morning. In the days that followed, the engineers laid each piece across long tables, pistons, rods, valves, intercooler lines, and the massive supercharger. They began measuring tolerances. That's when the first real shock came. Despite being mass-produced by the tens of thousands, the R-2800's tolerances, the microscopic differences in fit and shape were unbelievably tight. One technician reading his caliper muttered, "This is not possible, these are factory parts." Yet they fit like they were hand-built. It was the first quiet admission that something deeper was at play, not just engineering genius, but industrial muscle, on a scale Germany had never matched. Once the engine was fully catalogued, Reichlin's engineers began the process that truly mattered running it. They reassembled the R-2800 using American documentation captured from the pilots, a survival kit where maintenance notes and field manuals had been stored. The translation team worked overnight studying the diagrams that described a level of simplicity they found almost suspicious. When the first ignition test began, the tie hangar doors trembled. With a roar like artillery fire, the double Wasp came alive. 18 cylinders firing in perfect rhythm, prop wash swirling dust through the rafters. The men standing nearby instinctively stepped back, shielding their control ears. This wasn't the sound of a high-strung racing engine. It was a deep, steady growl, confident, unhurried. They ran it at partial throttle, first monitoring pressure gauges and heat levels. Everything held steady. Then they pushed it. Harder. 2,000 horsepower. Still stable oil. Temperature normal. Vibration minimal. Exhaust clean. The chief test engineer scribbled in his notebook, pausing occasionally to shake his head in disbelief. The Germans were used to coaxing every ounce of power from their engines, balancing a fuel mixture, by feel checking for detonation by ear, and dealing with overheating as a fact of life. But this engine didn't seem to care. It ran like a factory machine. When they disassembled the supercharger, another revelation came. The R-2800's two-stage, two-speed supercharging system was ingenious, simple to operate, yet profoundly effective. It delivered constant power from sea level to over 25,000 feet, and unlike the German mechanical superchargers, which required delicate adjustments and complex gearing, this one could be serviced in the field with minimal tools. Then came the turbocharger, a feature the Germans had largely abandoned for fighter engines due to complexity and heat management issues. But the Americans had solved those problems with robust heat shielding and smart ducting. The exhaust-driven turbine fed power back into the system seamlessly. When the team mapped the airflow patterns, they realized that the R-2800 was using every bit of exhaust energy the engine produced, nothing wasted. It was as if the Americans had turned brute force into efficiency. Menzel stood beside the roaring engine and said quietly to his assistant, "They've built a monster that behaves like a gentleman." In that moment, the Luftwaffe mechanics understood why the P-47 could dive from the stratosphere and climb again without melting its pistons or shredding its prop. It wasn't just power, it was control over power, and that realization was more unsettling than any Allied bombing run. When the test runs ended, the mechanics began cutting open samples for metallurgical analysis. What they found inside the metal left them silent. German metallurgy in 1944 was advanced. Their factories could still produce remarkable alloys, but shortages of nickel, chromium, and cobalt had already begun to erode quality. Every week, new directives arrived from Berlin, substituting one metal for another to conserve resources. The Americans, it seemed, faced no such limits. The R-2800's pistons gleamed with a finish the Germans could only describe as surgical. The connecting rods were forged from alloys that resisted both heat and stress, and when one engineer tested the hardness, the reading shot off scale. Even the cylinder barrels, which should have shown microfractures after test running, were pristine. The mechanics studied the cooling fins. Each was machined to exact uniform thickness stacked with perfect spacing. In comparison, the BMW 801's fins, though excellent, showed slight irregularities that affected heat dissipation, and then came the wiring harnesses. Every connector was insulated with a synthetic polymer that the Germans had never seen before. It was resistant to oil, heat, and moisture materials that remained stable even under combat conditions. When they ran a chemical test, they realized it wasn't natural rubber or standard bakelite. It was a synthetic derivative of a US polymer program. They had heard rumors of it neoprene. To the mechanics, that was nearly sorcery. But what impressed them most wasn't the chemistry. It was the consistency. Every component bore stamped serials uniform to the millimeter. Even the smallest washers were identical. One inspector remarked that the Americans had mastered something beyond mere engineering. They have built precision into their production lines. In German factories, skilled men adjusted and hand-fitted parts to perfection. In America, machines and workers together built engines that didn't need adjusting. That meant every P-47 engine, whether built in Connecticut, Kansas, or New York, performed the same. As they compiled their findings, the Luftwaffe engineers began to understand what they were truly facing. This wasn't just a superior design, it was an entire system of design and manufacturing working in harmony. The R-2800 was proof that America's industrial strength had evolved into something frighteningly efficient. Menzel's final note in the inspection log captured the mood perfectly. We build masterpieces by hand. They build monsters by the thousand. And as the war dragged on, the German mechanics knew there was no counter to that. As the evaluations continued, the engineers at Reich decided to go beyond routine testing. They wanted to know why Allied pilots spoke of the Thunderbolt's engine as if it were indestructible, so they devised trials that bordered on sabotage. The first experiment was simple: starve it of oil. They drained the sump until only a few quarts remained, then ran the engine at combat power. The expected outcome was seizure within minutes, but the double wasp kept running. 10 minutes, 20, half an hour. Temperatures rose. But the engine refused to quit. The Germans watched in disbelief. In their own engines, like the DB 605 inches, the Messerschmitt Bf 109, oil starvation meant instant death. Bearings would fuse, pistons would lock, and the engine would tear itself apart. But here, the R-2800 seemed to shrug it off. Next, they fired live rounds into the cowling to simulate battle damage. They struck cooling fins, severed wires, and even punctured an oil line. When the ignition sequence resumed, the Americans' monster coughed once, then roared to life again, spitting smoke and oil, but holding steady. The mechanics exchanged glances. They'd seen engines survive damage before, but not like this, not this calmly. They removed 2 cylinders entirely and ran it again at reduced output. It still produced power. That was when one technician murmured, "Das ist unmöglich, this is impossible." But it wasn't. The double wasp had been built with redundancy in mind. The radial configuration meant each cylinder could fail independently without destroying the whole engine. The wide cooling flow prevented local overheating, and its oil system could tolerate leaks that would ground any inline engine. To the Germans, this was a revelation. Their designs prized aerodynamic efficiency, long, narrow cowls that sliced through air. the Americans had accepted drag in exchange for reliability. And in war, reliability always wins. Menzel wrote in his notes, "The Thunderbolt engine can take punishment beyond mechanical reason. It is not merely an aircraft engine, it is a fortress." By the end of the week, they had come to a painful realization. Every German pilot who had seen a P-47 survive, heavy damage hadn't exaggerated. They had seen the truth. The R-2800 was an engine that refused to die. By October of 1944, the mechanics at Rechlin had completed their final teardown and analysis, but the conversation inside the hangar had shifted. It was no longer just about the engine's performance, it was about how it had come to exist. The R-2800, they realized, wasn't simply an engineering marvel. It was a symbol of the vast, industrial organism behind it. In Germany, engine construction was still a craft. Skilled machinists and engineers personally oversaw assembly, hand-fitting components, adjusting tolerances, fine-tuning the heart of each aircraft. Was art, beautiful, precise, and utterly dependent on individual expertise. America had gone another way entirely. Through their reports and captured production manuals, the Germans pieced together the staggering scale. Multiple factories across the United States. Pratt Whitney in Connecticut, Ford in Michigan, Curtiss-Wright in New Jersey, all producing identical R-2800 engines in synchronized batches. Each plant used the same tooling, same jigs, same gauges, and a supply chain capable of feeding raw materials by the ton. The result? Tens of thousands of identical engines, each as powerful and reliable as the last. Menzel walked through the hangar, past the stripped remains of the Thunderbolt's power plant, and said softly, This is not built by men, it is built by a nation." That single sentence captured what Germany's top engineers were beginning to understand across the Reich. It wasn't that the Americans had superior genius, it was that they had built an industrial civilization optimized for war. Production German factories were being bombed daily, their power grids failing, their skilled laborers drafted to the front. Meanwhile, American factories worked 3 shifts, fully powered, untouched by war, feeding endless lines of trucks, tanks, and aircraft to the ports. Every bolt in the R-2800 told that story. Every precision-fit washer, every gleaming piston, every redundant circuit, all of it whispered of a country that had turned its manufacturing into a weapon. The Luftwaffe mechanics compiled their findings and sent them to Berlin. The final report concluded with quiet resignation. In performance and reliability, this power unit equals or surpasses our best engines. In industrial reproducibility, it is beyond comparison. For the first time, the engineers at Rechlin felt something they had not known before: industrial envy. They could copy the design, perhaps even improve some aspects, but they could never replicate the machinery of a continent working in unison. It was clear now, the Americans didn't just outfight them, they had outbuilt them. In November of 1944, the final technical report left the Rechlin Test Center bound for the Luftwaffe's Engineering Directorate in Berlin. It was a thick document over 200 pages of data measurements and comparative charts. Yet the last paragraph was only 1 sentence long. In all measurable respects, the American Pratt Whitney R-2800 engine represents the highest level of operational power plant design currently in service. Those words, though formal and restrained, carried the weight of defeat. Inside the hangar, the men who had torn the engine apart stood around the now empty test stand. The once roaring heart of the Thunderbolt had been reduced to components each tagged, logged, and boxed, but the memory of its sound lingered in the air like an echo they couldn't forget. Some of the engineers lingered after hours, running their hands along the heavy crankcase as if touching a relic from another world. One of them, an older mechanic named Dieter Kranz, muttered to a colleague, "We believed we built the finest engines on Earth. Now I think, perhaps we built the most complicated ones." That distinction mattered. The Germans had chased perfection through enacted intricacy. The Americans had achieved it through endurance and simplicity. Weeks later, when Allied bombers began leveling German industrial centers, A few of those same mechanics watched the raids from the countryside and wondered if somewhere above them P-47 seconds, powered by that same roaring double wasp, were escorting the bombers home. They had studied its every bolt, every valve, every bearing, and they knew just how unstoppable those machines really were. After the war, several of the Reich engineers were quietly recruited by Allied intelligence. Their expertise was valuable, their knowledge of German and foreign engines even more so. When they spoke of the R-2800, they did so with something close to reverence. Menzel, who survived the war and later worked in civilian aviation, would tell younger mechanics, "The Americans didn't just build power, they built permanence. You can't destroy that with bombs." The captured R-2800 had done more than impress its examiners. It had changed how they saw the very nature of engineering. For a brief moment in that war-torn year, even the proudest Luftwaffe mechanics had looked into the heart of the enemy's machine and whispered the truth. They built what we dreamed of, and they built it by the thousands. When Germany surrendered in May of 1945, the Reich airfield fell silent. The test stands were cold, the hangars empty. Allied intelligence teams soon arrived, combing through the piles of captured documents and crates of foreign machinery, among them tucked away under load, a tarp in Hangar 7. They found the disassembled remains of that P-47 engine labelled in precise German handwriting. It was dusty now, its steel dulled by months of neglect. But to those who understood what it represented, it was more than a war trophy. It was evidence of an industrial truth the world could no longer ignore. The R-2800 had powered victory not through innovation alone, but through dependability. Its twin-row radial design would later influence both military and civilian aviation across continents. Post-war aircraft like the F-4U Corsair, the DC-6, and even early Cold War prototypes carried its DNA. For the German engineers who survived, the memory of that engine never faded. Some went on to work for Allied firms under Operation Paperclip and its European equivalents. In design meetings decades later, they still spoke of the double wasp, not as an enemy weapon but as an ideal. It had taught them that true power was not the product of one nation's genius, but of collective will industry, and the refusal to compromise durability for elegance. A few of those men wrote memoirs in the 1950 seconds, recalling the day they first heard the R-2800 roar to life in the Reichlin hangar. One wrote, "It was the sound of an entire first nation's machinery, not one man's brilliance, but millions of hands working in rhythm. In that sound, he said he finally understood why the war could not be won." The R-2800 double wasp remains even today a symbol of what happens when engineering meets industrial discipline, when strength is built not for beauty, but for endurance. And perhaps that's the final irony of the story. The men who once sought to defeat it ended up admiring it, because beneath the steel and pistons, beneath the roar and the fire, they had glimpsed something rare. The pure power of human ingenuity harnessed without limits. It wasn't just an engine, it was a statement. And for the men who examined it in that quiet hangar in 1944, it was the moment they realized. The war of machines had already been decided.